years of experience in this role have unveiled both the opportunities and challenges associated with digital transformation, and he will use this experience to talk to us about navigating challenges and building synergy in data-driven research across disciplines and organizations.
Thank you. When I saw the title, I was a bit surprised, really. It was a very comprehensive title, but I soon realized it was my own making a couple of months ago. And after reading it a couple of times, I also see that there is a story there that I would like to tell. The data-driven, let's say, trend is, in my opinion, maybe the strongest is most important in what we call kind of the digital transformation of the geosciences, and I'll try to tell a little bit why. So I start with an example from NGI, which illustrates what we mean by this being data-driven. In offshore wind has been mentioned from several speakers already. Wind farms are huge. There is so much more data that you need to work on to make a ground model, which you're going to use for your design than what it used to be. So there is huge amount of geophysical data, there is huge amount of geotechnical data, and basically the ability to use those data by all these new, let's say, fancy technologies, machine learning, AI, geostatistics, and all that is really where we are heading. And if you go 10 years back, we work now in a completely different way with these projects. Another just example, which I like to show, you have probably seen this picture before. It's much used, but outside geotechnics, and it basically does a nice illustration on what have happened in terms of showing the power of data. This 10-15 years ago, the oil majors were the most valuable companies in the world. That is not the case anymore. The most valuable companies in the world are the companies that owns data and has the ability to utilize those data into market value. And that's actually for me, very fascinating shift. Which shows really the importance of it. Another field outside geotechnics, which I also think is worth to mention, which kind of underline the power of data, is how we were able to cope with the COVID pandemic. It was a fantastic achievement from the medical science that we were able to come up with the treatments and the vaccines as fast as they could. And a very kind of fundamental driver behind that was the ability to share data. So the DNA sequence of the virus that was shared already as early as mid-January. And that was continued throughout the pandemic. So every time a new version of the virus came, this was sequenced and was shared. So that means that you were able to mobilize, the whole research community everywhere in the world to work on that, with the medical treatments that was necessary. So the use of preprint data sets that was made available were accelerating in this period. So I think it's something for inspiration for us. We don't fighting pandemics as geotechnical engineers, but it says something about the pace of scientific progress, really, and technology progress. So there's two main components that goes into this. You need to have the data and you need to have the competence to use it. And this is not straightforward. I like this figure as well. It's just a very simple survey that was carried out by the technical community on machine learning and big data in the International Society of Soil Mechanics and Geotechnical Engineering. And it just asked what's the biggest obstacle in actually using machine learning and statistical methods and taking that into use in our profession. And the biggest hurdle is basically the data. So all these jokes about what data scientists do, cleaning the data is 70%, explaining what you do is 20, and then using the machine learning techniques is 10. It's true, and I think people. So if you have the same feeling, you're not alone. The blue column is all of those that are missing data. So we need to develop digital infrastructure if we would like to advance, and NGI has put their effort into this. We are developing what we call GeoHub, and that is basically not one big thing, but it's a set of different applications that directly pointing to subsets of data that are important for us as geotechnical engineers. And you have all those there in the, let's say, in the platform, and you can actually extract and use those data as a scientist on the right side and analyze those. So if you go, as I said, this is one thing. There is different type of applications. I'll spend a bit of time to show you what it is, but just to highlight the importance. So this needs to be built in the right way. So you need to have the modern technology stack to ensure that this is scalable, that it's robust, and it's secure. And that is not something that geotechnical engineers can do, at least not those that I know. So you need professional developers to this, and that's a little bit behind the reasoning behind founding this team, NGI Digital. Just a few examples what's in there. This is NGI Live. It's basically a service for accessing on live data. One thing is the dashboard, but it also is a backbone there, which takes in the data, process it, and make it available here. This is from the research station, the snow avalanche station at Fonbu. That's at NGI research facility on the west coast of Norway. And these are now available for all of you that would like to look at these data. Another important application for us is what we call Field Manager, which is basically contain what we typically think is the most important technical data from the lab and from the field. That's going into the solution, which is a data platform, but it's also developing, let's say, project support and process support to get people to use it, because that's quite important. Get Jan mentioned the incentives actually to use those data and get the data into it. So that's an important part of it. And of course, then you can use the data through APIs for analysis and interpretation. So this is also an application that we offer for external companies and organizations. Not going into details, but it's basically map-based and gives you quite much support when actually executing the site investigation as well. But this is kind of then the key thing, that if you have, a data platform like this, you can plug into that both as an internal user, but also as an external user. It's a little bit federated or not. It's the key thing here. Of course, is that you have the same kind of the same value proposal, that there is people outside the organization that has a lot of benefit to work with your data. And of course, there comes all the synergies, and I think that's really a key in the digital transformation. It is really enabled to collaborate in a way that we didn't do before. So of course, it means I can actually use the data from someone else to innovate, and it's basically the end of the, let's say, the classical innovation of the firm that's kind of within in an organization's boundaries. Just to be a bit more precise on where these synergies may arise. One thing is within research projects like this, then you have the same discipline. We are sharing data in a much more professional way than what we did 10 years ago. It wouldn't be the same. So it's fair. But still, we need to ask the question, okay, is it equally easy to use my data as it is to use another's data? Are we really there? And I think there is something that we still need to work on, make this machine readable and also establish APIs for the most common data sources so we can use it even more effectively. So I think is something we should look at in the future. Another thing is the synergies across industries and research, because in very often, the industry produce data that has a research interest. It's not like these are just a lot. I think this is also close to all the NGI projects that is performed since 2016 or something. And of course, there's a lot of data there, and most of these data are not collected or gathered in a research context. It's an industrial context, but of course it's a huge research potential in this data, and that is of course that is only NGI, but of course a lot of industrial players have similar data sets, which is so valuable, and that is something we need to work on, the collaboration industry, academia, and I think the new technologies are an enabler for getting that to work. The other thing is even a little bit similar to what Gert-Jan mentioned. When you have synergies across both domains or organizations, and of course, it's physical phenomena is very seldom restricted to one technical discipline alone. So we need to have that interaction to increase our understanding and also develop more advanced prediction methods. And of course, that is also to build IT systems and architecture that communicate with each other in an efficient way is extremely important. This is just a simple example of that, where for a study of a colleague of mine did on a Chinese landslide for predicting displacement, where you use water reservoirs and you use precipitation and we use displacement data to in a machine learning technique, to get better predictions. And there are different owners of that data, but you need kind of the power lies in combining them. I think I'm running over time, so I need to. There are some interesting examples, but I need to skip those. So just would like to say a few words about the challenges, because there are challenges. If someone thinks this is very easy, please see me after the presentation. I would like to hire you. It's but I think some of the challenges are human based, and they are not here because they represent specific challenges. There is one guy from NGI Digital. There's also Sebastian, which you may know, central part of the GeoLabs consortium, and actually get the experts on both sides to talk with each other and actually be curious about how the digital infrastructure is going to facilitate what you do as a researcher is extremely important. If you have the expectations that the other side will give you what you want specified clearly, it will not work. And we see that when we get that communication going, then we're able also to advance on the field of digitalization. The other thing is actually to find out when is the right timing, to impose these new technologies and these new tools to work on. We all know the Gartner hype curve, but you can say in this project we are going to work with in a new way that starts from now. Maybe that will actually kill that project because it's so difficult. If we say we are only doing this as we did in the last project because this project counts, we will be there in 10 years and have progress. So that balance, at least I think that is extremely difficult. The other thing is it's also challenging how autonomous you can work as a researcher. Can you do when you have your own data, your own codes? You can do whatever you like, and it was no one else's business. But of course, with a new set of working, need to be challenged. You have a common set of data, you have a common code base that need to be shared, and you need to adapt to some common practice in this. And then, of course, that as well, we don't want to be too strict because then you kill the creativity. But you can't, it can't be as everyone would like it to be. So that's also a challenge, I would say, in this thing. NGI, of course, the key thing is this is competence. So NGI has started off what we call NGI Code Academy. That is has started off as an internal, let's say, as internal training with different courses that people can attend. We are also considering to make that available for external researchers and engineers. So if that is of interest, please notify us. And that was it from me. Thank you.
Thank you very much.